Igneous rock. This is the oldest type of rock on Earth, formed when molten material from deep inside the planet cools and solidifies. That molten material, called magma, can cool slowly underground or reach the surface through volcanic eruptions where it becomes lava. When it cools slowly, large crystals have time to grow, producing rocks like granite. When it cools quickly on the surface, the crystals are tiny or sometimes absent entirely, as in basalt. Igneous rock forms the foundation of most of the Earth's crust and is found on every continent. Sedimentary rock. Over thousands of years, particles of sand, clay, shells, and organic matter are carried by wind and water and deposited in layers. As those layers pile up, pressure compresses them into solid rock. Limestone, sandstone, and shale are among the most common examples. This type of rock often contains fossils, making it essential for understanding ancient life on Earth. It covers about 75% of the land surface, even though it makes up only a small fraction of the total crust. Metamorphic rock. When existing rock is subjected to intense heat or pressure, or both, it transforms into something new without actually melting. The original material changes its mineral structure, texture, and sometimes its appearance entirely. Marble, for instance, begins as limestone before heat and pressure reshape it into its smoother, denser form. Slate starts as shale and becomes harder and more layered. These rocks are commonly found in mountain ranges, where geological forces have pushed and compressed the crust over millions of years. Granite. One of the most familiar rocks in the world, granite is an igneous rock that forms deep underground from slowly cooling magma. Its distinctive speckled appearance comes from visible crystals of quartz, feldspar, and mica, which grow large because the cooling process takes a very long time. It is extremely hard and durable, which is why it has been used in construction and sculpture throughout human history, from ancient Egyptian monuments to modern kitchen countertops. Basalt. This dark, fine-grained rock is the most abundant rock type on the ocean floor and forms wherever lava cools quickly after reaching the surface. The rapid cooling leaves little time for crystals to develop, giving basalt its smooth, dense texture. Much of Iceland is built from basalt, and the famous Giant's Causeway in Northern Ireland consists of thousands of basalt columns formed by ancient lava flows cooling in a remarkably regular pattern. Limestone. Formed mostly from the remains of marine organisms such as coral, shells, and tiny sea creatures, limestone accumulates over long periods at the bottom of shallow seas. As organisms die, their calcium carbonate skeletons pile up and eventually cement together into rock. It dissolves slowly in slightly acidic water, which is why limestone landscapes often develop caves, sinkholes, and underground rivers. The White Cliffs of Dover in England are made almost entirely of a fine-grained form of limestone called chalk. Sandstone. Layers of sand grains, usually carried by rivers or wind, settle in basins and gradually harden into sandstone over time. The color and texture of the rock depend on the minerals present and the conditions under which it formed. Red sandstone gets its color from iron oxide, while white or pale yellow varieties tend to contain purer quartz. It has been widely used as a building material across many cultures, and many canyon landscapes, including parts of the American Southwest, are carved into ancient sandstone formations. Marble. Marble begins as limestone but is transformed by heat and pressure into a much denser and more crystalline rock. The process realigns its mineral grains, giving marble its characteristic smooth texture and the ability to take a high polish. It has been prized by sculptors and architects for thousands of years. Michelangelo's most famous works were carved from Carrara marble, quarried in northern Italy, a source that has been used continuously since Roman times. Obsidian. Formed when lava cools so rapidly that no crystals can form at all, obsidian is essentially volcanic glass. It is usually black and has a very smooth, shiny surface with extremely sharp edges when broken. Early humans recognized these qualities and used obsidian to make cutting tools and arrowheads long before metal was available. Despite looking fragile, obsidian breaks in a predictable and controlled way, which made it one of the most valuable materials in prehistoric toolmaking. Quartzite. When sandstone is subjected to heat and pressure, the individual quartz grains fuse together into quartzite, a very hard and dense metamorphic rock. Unlike sandstone, which can crumble along the boundaries between grains, quartzite breaks through the grains themselves, making it far more resistant to erosion. It is commonly used in flooring, road construction, and as a decorative stone. Shale. The most common sedimentary rock on Earth, shale forms from fine particles of clay and silt that settle in calm water environments such as lake beds and deep ocean floors. Over time, these thin layers compact into a soft, layered rock that splits easily along its natural planes. Shale is significant not only as a fossil-bearing rock, but also because it serves as a source rock for oil and natural gas, trapping organic material that transforms into hydrocarbons over millions of years. Pumice. When volcanic eruptions produce lava full of dissolved gases, the rapid release of those gases as the lava cools creates a rock riddled with tiny holes. The result is pumice, a light and porous rock that is sometimes so full of air pockets that it can float on water. For centuries, it has been used as an abrasive material for smoothing wood, skin, and other surfaces. Some of the largest pumice deposits on land were left behind by ancient eruptions of extraordinary scale. Slate. This fine-grained metamorphic rock develops from shale when moderate heat and pressure cause the clay minerals to recrystallize and align in flat layers. That layered structure allows slate to be split into thin, smooth sheets, which made it a common roofing material in Europe and North America for hundreds of years. It is also used for flooring, chalkboards, and billiard tables. Regions like Wales in the United Kingdom have entire villages built almost entirely from locally quarried slate.